In this tutorial, we're going to continue working the example of our system of 3 equations and 3 unknowns, and we are in particular going to evaluate the inverse of G, the matrix G. We found last time that the inverse G is equal to the transpose of the cofactor matrix divided by the determinant of G. And so what we're going to do this time is we're going to begin by evaluating the cofactor matrix. Remember that the cofactor matrix has in each position of the matrix the cofactor of the ijth element of G. And the way we compute that is, and I'll do this for the 1, 1 element, we'll cross out the first row and the first column. We'll calculate the minor, which is the determinant of the matrix that remains, so that's 4 times 1, 4 times 1, and then we multiply that by minus 1 raised to the I plus j, which in this case is 1 plus 1. Sorry, minus 1 times, minus 1 to the 1 plus 1. So our first entry here is going to be 4. Actually, let's erase all of this. Okay, first entry will be 4. Second entry, we will cross the first row. Oh, my pen's not working now. Okay, the second element is computed by crossing out first row, second column, leaving a minor of 2 times 1 minus 0 times 0. So that's 2, but we're now going to do minus 1 to the 1 plus 2 times our 2 times 1 minus 0 times 0. So we will have minus 2 here. The third element will be 2 times 0 minus 4 times 0. So that's going to be a 0 entry. And then moving on to the second row, we will have 3 times 1 minus 0 times 0, and that's an odd position, so we will have minus 3. Cross out row and column 2. That leaves 1 times 1 minus 0 times 0, and that's a positive position. Then the 2, 3 position, and that again gives us a minor of 0. 1 times 0 minus 3 times 0. Last row, we'll have 3 times 0 minus 4 times 0. We will have 4 times 0 minus 2 times 0. And then lastly, we will have 1 times 4 minus 2 times 3, 1 times 4 minus 2 times 3, times minus 1 to the, and this is going to be 3 plus 3 position. So that's going to be even, that'll be plus. So we have 4 minus 6, or minus 2. So we've computed the cofactor. Now we need to take, remember, the transpose. The transpose of the cofactor matrix will be, we'll put the diagonal down first. We'll flip the minus 2 and the minus 3, and the rest of the matrix is just 0 entries. It's kind of ugly. Minus 3, 1, and 0. Okay? Now lastly, we need to compute the determinant of G. Okay? Now, I've not shown this yet. I think there's a different tutorial to show the determinant of a 3 by 3, but let's just work it here. So the way we do this is we take the minor, actually let me write it out, it's going to be the determinant of G will be, for this is for a 3 by 3, I'm going to write it, will be the first element. There's a lot of different ways you can do it. You basically go along any row or any column and you will be summing n terms. In this case it's a 3 by 3, so we're going to be summing 3 terms. I'm going to going across the top row. Okay, so I'm going to go across this top row, and that you'll see what I mean in a moment. So we're going to have A11, that's the first, that's the element at position 1, 1, so that's 1 in this case, times the cofactor at that position, plus, which, okay, C11 there is going to be 4, right? Plus A12, that's going to be 3, this element here, times C12, and that's minus 2, plus A13, which is 0, times C13, and that is 0. Okay, so what we do is we take, if we go across, say, the top row, we take that element, 1, and we multiply that times the determinant of this 4001 matrix. So it's 1 times the determinant, which is 4 times 1 minus 0, so it's 4. And then lastly, we multiply, we have to change the sign if it is an odd entry. So the odd entries, right, so odd, call it odd entries, are going to be these right here. Right, so wherever I plus j is odd. Right, so that's where we'll have sign changes. So the determinant here turns out to be 4 minus 6, which is minus 2. Now let's, just for kicks, we can calculate this a different way. Let's go down, let's go going, let's say, let's go going down the far right column, and this would be the easiest one. Okay, so what we'll do is we're going to go down here. So we'll have a term, it would be A13 times C13 plus A23 C23 plus A33 C33. Alright, so that's moving down in this direction. But A13 is 0, A23 is 0, and only A33 is non-zero, and so we really only have one term to contend with. You only need the cofactor C33, which we have found up here to be minus 2. And so here we find the determinant to be minus 2, which agrees with how we calculated it previously. So we are now arrived at the inverse of G, and that is, it's the cofactor divided by the determinant, and which is minus 2. So we're going to go back up, we're going to pull from this up here, bring it down here, right, and just divide everything by minus 2. So we'll have minus 2, because it's 4 divided by minus 2, plus 3 halves, 0, 1, minus 1 half, 0, 0, 0, and 1. Now we need to check if this is indeed the inverse. Okay, check. So we can do G times G inverse, or G inverse times G, and minus 2 minus 3 halves, 0, 1, minus 1 half, 0, 0, 0, 1, times our G. Okay, so we've got a number of calculations here. Alright, here we go. So let's determine the 1, 1 term. Okay, so we're going to go across and down. So we will have minus 2 times 3, or minus 2 plus 3 halves times 2. And that will give us minus 2 plus 3, which is 1. And that's what we would like to see there. Now we're going to move across to the second column, because we want to fill in the 1, 2 position. And there we will have minus 2 times 3 is minus 6, plus 3 halves times 4 is plus 6. And the last term is 0, and that equals 0. And then looking at the last term, we see that that one's going to be 0 as well. Going to the second row, we have across and down, we'll have 1 minus 1/2 times 2, which gives us 0. And I think I will not carry out all of this. Let's just check one more. Let's do the two more. Let's do the diagonals here. So we'll move on to the 2, 2 position. So there I'm not thinking straight. It's going to be 3 minus 1/2 times 4. I'm going too fast. Is equal to 1. So there's 1. And our last element in the diagonal, the 3, 3 element, will be pretty easy to calculate. It's all zeros except for the 1. So you can fill in the rest, but you should find that we get the identity matrix. Right, equals I, therefore G is, or the G inverse as found here is in fact the inverse of G. Now lastly, how do we actually arrive at our intended goal? From the beginning, we were after finding what V was, these voltages V1, V2, V3, and we found that if we could simply determine, determine G inverse, we could solve for V. So let's do that. Recall that S is equal to 1, 2, 3. Okay, vector 1, 2, 3. So let's write that out now. So we're going to find V. So V1, V2, V3 is equal to, and here we write our G inverse. So this is G inverse. It'll be minus 2, 3 halves, 0, 1, minus 1/2, 0, 0, 0, 1, times S. And here, S is 1, 2, 3. So this will, since we're multiplying A3 by 3 times A3 by 1, we're going to have A3 by 1. So multiplying across and down, we have minus 2 plus 3 halves times 2. That's going to be minus 2 plus 3. Minus 2 plus 3, that will be 1. The second row will be 1 times 1 is 1. Minus 1/2 times 2 is minus 1. And the last entry is 0. So it appears this output is 0. And then the third row is simply going to be 3. So there you have it. We have found V1, V2, V3. V1 is equal to 1, V2 is equal to 0, and V3 is equal to 3. And that is how you can solve a system of 3 linear equations by matrix inversion, carrying it all out by hand.